Welcome to DevCon. Myself Ajitesh, and I'm a custom engineer at Google Cloud. I basically work with select conglomerate and digital native FSI customers, and I help them on their journey to build and innovate on Google Cloud. So though my main focus area is infra modernization and app mod, including application development, but today I'm going to talk about something different, which is data replication from a OLTP database in a multi-cloud environment. So this use case came to me a couple of months back when working with a customer when he was, or when the customer was already working on one cloud platform, but they wanted to leverage the vast capabilities of data and analytics on GCP. They wanted to replicate the data from that cloud provider to GCP to run their analytics. And at that point of time, I came up with this solution, which is data replication at scale, and which is with zero downtime. So this is the agenda for today. We'll first look at why do we need data replication. The second, we'll just briefly touch the multi-cloud strategy. Next, we'll move on to the solution, which I'll be presenting. And at the end, we'll do a quick demo, which is for me the best part. Cool. So let's move ahead. Let's talk about why do we need data replication. So generally, the operational data needs of an organization are addressed by an OLTP database, which is your online transactional processing systems. So these OLTP systems are basically very important in your day-to-day business. Okay, but if you see, they are not perfectly suitable for decision support queries or business questions that your manager or executive would need to address, because such information or such questions involve analytics, which includes your aggregation, drill down, slicing and dicing of data, transformation of data, and those operations are mainly supported by your OLAP system, which is your online analytical processing system. So for an OLAP system, you have data warehouses like Bigquery, which support OLAP applications by storing and maintaining the data in a multi-dimensional format. So when the data goes in these OLAP warehouses, they are extracted and loaded, and this could be loaded from multiple data sources. This could be either your Postgre database, either your MySQL, either your Oracle, or either it could be a flat file. So there are a number of data sources from which your data warehouse gets the input to. Now, we already spoke about why do we need the replication. Now let's talk about a bit about multi-cloud strategy. So a recent HBR article on multi-cloud suggests 75%, let me repeat, 75% of enterprises are already using more than one cloud platform. Okay, so now when all these customers are ending up multiple clouds by chance, why should not we make multi-cloud strategy as a choice? From my point of view, all the organizations shall plan this chaos before it goes completely out of hand and develop a multi-cloud strategy just to plan for the future and your technology roadmap. So if we talk about lock-in, so none of us would like a lock-in basically. So similarly, none of the customers like to have a vendor lock-in, which would limit their freedom or which would curb their freedom. Also, if we see one solution never fits everyone, right? So you should look towards customizing your cloud architecture, which would suit your needs, which would optimize your cost, and choose the best of breeds across all the cloud providers. So basically, you should look towards building with the best tools and technologies which are available across the providers. I myself am working with multiple customers who are running their applications on various other cloud providers because they started early on those, but now they are leveraging Google Cloud for the vast data and analytics, which is on GCP. So that's where your the whole multi-cloud strategy makes sense. So moving ahead, let's talk about the architecture. So the architecture for the solution. So if you see the solution, this is segregated in two parts. So one, on the left-hand side, you have the box, where you have your PostgreSQL. It could be either of the cloud providers. It could be either your Amazon, it could be either Azure Postgre, or it could be a Postgre on VMware, right? So that's your left box where your data is, right? On the right hand side is your solution, which is deployed in Google Cloud. So on the right hand side, if you see, right, so you have Debezium, which is an open source solution, which is deployed on GKE. Then you have Cloud PubSub, and then you have Cloud Dataflow, and then you have Cloud Bigquery. So now, if you see, the data comes from the Postgre database, which could be either on Amazon, Azure, or on-prem. Then it gets the CDC or the change data capture is done, and then the data is pushed to your PubSub. So basically, PubSub is used to ingest the data, okay, and then it moves to Dataflow, which is a serverless, and then again it moves to BQ, from where it could be again utilized by BI engine, BQ BI engine, or BQML. So that's the complete solution which I built. So let's talk about the first part, which is the CDC Capture, which is the change data capture with Debezium. So Debezium, basically, it's an open source distributed platform for change data capture. Once you configure it, what it does, it connects to the source database, and it takes a consistent snapshot of all the tables or selective tables. So it all depends on you, what you have configured. If you have configured the complete, or if you have configured selective tables, it would be taking a snapshot of those tables. If you have configured for all the tables, it would take for all the tables. So after the snapshot is complete, the connector continuously captures the row level changes. Either it could be insert, either it could be update, or either it could be delete, which we are committed onto the source database. And then the connector generates your data change event records, which are then streamed onto your PubSub topics. Okay. And the default behavior is, for each of the table, you should have a separate PubSub topic. So if you're trying to do CDC for 5 tables, you need to have 5 PubSub topic created for them. And this Debezium, if you see, this is deployed on GKE, Google Kubernetes Engine. I won't go in details of GKE. I believe everyone is aware about the capability and the enriched features which GKE has and what GKE provides. So I'll just skip the GKE part. Moving ahead, so after the CDC is ingested, the Debezium has published it to the PubSub topic. Then what you can do is you can build your end-to-end streaming data real-time analytics pipeline. Okay, and that could be built with Cloud PubSub, which is your massively scalable event ingestion service provided by GCP. And then the next comes is Cloud Dataflow, which is a serverless streaming data processing service. And at the end, it's your BigQuery, which is one of the most loved Google Cloud service. Okay. And so if you see in this diagram, you see Dataflow and BigQuery. So there's a deep integration between Dataflow and BigQuery, which makes it quite easy and seamless for our customers to operationalize their real-time analytics pipeline without worrying about any infrastructure, without worrying about any system engineering. So the analysts have to just focus on the analytics. They don't need to worry about the infrastructure, what's behind. So GCP handles the automated scaling and performance for you. You don't need to do anything. Now, before we go deep down into the complete solution of real-time analytics, of real-time data analytics, let's talk about the example architecture for data analytics. So here I have considered a popular mobile game. You can consider any mobile game, and which attracts like millions of players and generates terabytes of game-related data in a very short period of time. So this infrastructure, or this ingestion of terabyte of data, rather generation of terabytes of data, it places extraordinary pressure on your infrastructure. Okay, and that requires a scalable data analytics, so that you have your timely and actionable insights, and that too in a cost-effective way. Almost all the companies, they are using Google's WebScale analytics service, which would create personalized experiences for their players. And they use telemetry and smart instrumentation to basically gain insight, okay, onto how the players engaged in the game, and to answer questions like what level is the player stuck? Is that level too hard, or are the players able to clear that level in a very short span of time, right? So these questions are answered by your analytics. Okay, so now if you see, you have two blocks. One says batch processing and one says real-time processing. So the batch processing, this pattern helps you process game logs basically, and I'd say other large game files, and this is done in a fast and a parallelized manner. Okay, so this is like take a batch and then process it, right? The next thing is your real-time processing. So this pattern basically use it when you understand what's happening in the game at that point of time. Okay, so Google Cloud PubSub and Dataflow provides a fully managed way to perform a number of data processing tasks like cleansing, transformation, and even you have fraud detection could be done in real time, right? So with real-time analytics, you can highlight a player with maximum hit points outside the valid range, or even you could be publishing the dashboard at the real time with the player scores. Okay. So now here, if you see, then after you have the real time and the batch processing data ingested into PubSub, then your cloud data flow comes into the picture. It loads the processed data, which was transformed and extracted, and it loads into one or more BigQuery tables or BigQuery data sets. Your BigQuery is built for very large scale, okay, and it allows you to run aggregated queries against I'd say petabyte scale data sets, and that too with a very fast response time. Okay, so that is great for your interactive analysis and data exploration. Okay, so if you see at the right, so then your BigQuery, the data sets that could be consumed with your other stuff like Tableau, or you can use Looker to visualize the data, or you can use BI engine, or you can use BigQuery ML. So that's the overall architecture, which is the basic architecture for a data analytics solution. Now let's move on to the solution which we have built. So after Debezium, we have Cloud PubSub. So Cloud PubSub, as I said, it ingests event stream from anywhere and at any scale, and it could be used for your real-time stream analysis. If you see at a high level, Cloud PubSub is basically a publisher and a subscriber service. So a publisher publishes a message to a topic, and then you have subscribers who subscribe to those topics. So once the messages are published, the subscribers get those messages. Okay, so the one what I'm showing here, that's the simplest form of the pattern. And here we have the other patterns which are possible. So if you see on the left, that's the one which we covered the last in the last slide, where you have one publisher and one subscriber. So what it does, this decouples your publisher and subscriber, and all what you know, what we need to know is how do you read and write to a topic, nothing else. You don't need to worry about anything else. It scales automatically, so you don't need to worry about that. Next, if you go, so in the middle you have multiple publishers writing to a topic, and multiple subscribers which are sharing a subscription, which means messages are distributed to the nodes. Okay, and this allows you to parallelize over the messages in a topic. So you have one topic, one subscriber, you have multiple subscription listening or running with the same subscription. Okay, at the end, what you see, that's the publisher writes to a single topic, and then you have independent subscribers which receive all the messages. So that's how the basic patterns of a PubSub architecture. Now, in PubSub, you have two delivery methods. One is your pull subscriptions, and the other one is a push. So pull is where your subscriber pulls the data from the topic, and the other one is where your topic pushes the data to the subscriber. So those are basically the two delivery methods provided by PubSub. If we talk about performance, so PubSub is fast, and it's like it takes less than 150 milliseconds for 99% of the time for publish, and less than 1%. Less than 1 second for the 99.9% for the end-to-end transaction. And it's a scalable. When I say scalable, so it can go from 1 kbps to 100 gbps, and that too with consistent performance. Moving ahead to our next block in our architecture, after data has come to the PubSub topic, and now the PubSub topic related to data flow. So what is data flow? Basically, a data flow is like a MapReduce framework. You can say it Hadoop and Spark, or you can say it a programmable BigQuery. And this is the framework which is used to power Google's internal data analysis for last many years. So just imagine how powerful it is, right? So it's been built for ages, it's evolved for ages, it's evolved for years, and now it's out to be used by everyone or to be consumed by everyone. Okay, so what data flow offers? So what data flow does is, so basically it manages resources for your scaling. So it takes care of scaling up and down. You don't need to worry again about the infrastructure. Okay, then it distributes your work across whatever graph you define. Okay, so I use it's a map and another two reduces, or whatever you want to name it, right? So it's not just a map and a reduce, and it scales out to the number of machines, so that with a similar computational cost, you get results which are much faster. Okay, so if I go in detail, so what data flow does is it abstracts away the complexity of your data pipeline management by simply automating more typical manually streaming intelligence functions than any other vendor available in the market. It's highly automated, it's fully orchestrated, it's ultra simplified, and widely efficient. Okay, so now I've spoken 4 jargons. Now you'll ask me, what do you mean by highly automated and fully orchestrated? So let me go through them. So highly automated, because your data flow is serverless, auto scaling and auto provisioning comes naturally, and that comes with a petabyte and exabyte scalability, right? Because your data engineers spend a big amount of time for break and fix, we have also built in self-healing, right? So data flow does your auto scaling, it helps in self-healing. Also, it automatically optimizes your performance, it provides you performance boost, it balances your workloads to ensure everything is in real time or just in time responses for your big business events. So that's mainly when I speak about highly automated. Now, if I say fully orchestrated, so as your number of data pipelines in your organization grow, data flow comes with a flexible orchestration parameters. Okay, so you can tamper orchestration based on users, workloads, or outcomes. Okay, data flow, what it does, it makes it to combine and cost optimize batch and streaming pipelines, right? So it does as a cost, it does everything in a very cost efficient way. And there are also multiple based pricing, which makes data flow very much affordable for all the data pipelines. So that's about why when I call it as fully orchestrated. Now let's talk about ultra simplified, right? So as a data engineer, you can use any of the several languages or notebooks to create your data pipeline. And you can just tap into the vast resources to create all your pipelines with a SQL. Okay, or else you can just plug in your Beam software development kit, and you can just move forward it open source, right? So it's just simplified. Almost everyone knows SQL, and it works with SQL as well. So that's just very much simplified. Now let's talk about widely efficient. So it brings maximum efficiency to your performance, utilization, and time to insight. So you have resource optimization, which automatically occurs for pipeline performance at any scale, right? So if you see, it's all efficient. You create the pipeline, and then your optimization happens at the runtime, or it happens automatically. So that's where it's widely efficient as well. So now, if you see in the diagram, you can replace all the various data handling tools with just data flow. So that's what data flow provides. So take out multiple tools and just bring in data flow, which would solve all your purpose. And at end, if I'd say data flow is no ops, so you really, it's all serverless. Now let's move ahead. So let's talk about a few of the data warehouse woes. So if I talk about the problems with the current data warehousing solution. So basically one is your licensing. So every time you have to renew the license, which is a very much hassle. Then your systems, they can't keep up with the forecasted usage and the data growth. So there's nothing like serverless, which would scale automatically. So you have to keep that thinking in advance, and you have to prepare for it beforehand. And then I'd say if you see your legacy system, that busts your budget as well, right? So even if you're not using the pipeline, you're incurring those costs, right? So let's talk about big data, right? So Google's mission, if you know, is to organize the world's information and make it universally accessible to everyone and make useful, right? So Google is now exposing its technology to customers through GCP. Okay. Basically, you can use the same technology which we have been using or for Google success to enable your own success. Okay, so that's the mantra we follow at Google. Now, talking about data warehouses use cases. So if you see the traditional data warehouses, they have gone beyond it, right? So now they need a 360-degree view of the business data, which is very much valuable. Okay, and as the cost of storage and data processing reduce, now enterprises want to process, store, and analyze all relevant data sets, which are both internal and external to the organization. The second thing is every organization now wants to be situationally aware and responds to real-time business events. So as soon as some event happens, they want to gain insights and they want to leverage that. So that's where your latest data warehousing solution helps you. Next thing is if you see from the traditional warehousing solution, so now the organization needs a reduction in the time to insights. What it means is earlier when you have to get some information, you have to get up and probably provision some hardware, put some software, and then you need to run your analytics on it, right? Now organization wants it at real time and very quick, right? So that's where the new warehousing solutions are involving, right? Also now with so many cyber attacks, everyone needs a simple and powerful data security and governance. So your data needs to be secure but accessible to the right stakeholder, which could be inside and outside of the enterprises. So that's about how your data warehouse is changing from traditional to the new generation. Now we spoke a lot about your traditional warehouses. Now let's come to the solution. Now let's come to the solution of moving away from your traditional warehouses. Let's talk about Bigquery. So Bigquery is a fully managed enterprise data warehouse, which helps you to manage and analyze your data. And Bigquery has built-in features like machine learning, geospatial analysis, and BI, which is business intelligence. It also comes with a serverless architecture that lets you use SQL queries to answer your org's biggest questions with basically zero infrastructure management. So again, this is serverless. So you're doing analytics at serverless scale. Okay. So the scalable and distributed analysis engine inside the Bigquery that lets you query terabytes in seconds and petabytes in minutes. Okay. It maximizes your flexibility by what Bigquery does is it separates the compute and it separates your storage choices, right? So which maximizes the flexibility. Now let's talk about serverless data analytics, right? Let's talk about the importance of serverless, right? Now it's a completely different approach to analytics. What was traditional? Rather than thinking of managing your data analytics infrastructure, now we are shifting towards focusing completely on analytics and insights by removing your conventional steps of your IT operations. So why do you choose GCP or why do you choose Bigquery to help with your big data need, right? So I'd categorize this in three parts. The first being ease of use and setup. We all know big data is difficult and we just talked about it. Unlike other cloud providers, Google provides the industry's only no-ops big data platform. No-ops means that application developers will never have to speak with an organization or with an operations engineer. Okay, they just need to focus on the analytics. The second is the speed of iteration. So a lot has been written basically on the speed of iteration. How does it beats the quality of iteration? So when it comes to big data, we're pretty sure you won't get it right the first time, neither the second or the third time, right? So to win these days, the solution resides on how quickly one could iterate, right? So we believe in speed of iteration. You learn from your mistakes, you learn from your problems, and you iterate, and you build up new versions and solve your problems. And the third being is your low TCO. So GCP does not only offer competitive pricing compared to the competition, we help you reduce your cost with a fully managed big data solution, resulting in less man hours to process a job, right? So that saves you a lot of money as well. So now when we look at why we have many customers deciding to move their data to BigQuery, it's because BigQuery solves many of their issues within their traditional warehouses, right? So with BigQuery, you'll be able to automate data delivery with BigQuery data transfer. You'll be able to share queries and result sets among users within your organizations. You can set the foundations for advanced and real-time analytics. And also you can significantly reduce the effort which is generally required to maintain a data warehouse solution. And to give some sense, so 10.5 trillion, that's the largest query, 5 petabyte, that's the largest data size, 250 petabytes, that's the largest storage customer, and 4.5 million rows per second, that's the peak ingestion rate. So these are just amazing figures. And by these figures, you can just understand the scale of BigQuery, what it provides to the organization and what it provides to the customer. Okay, so we have covered about the complete solution. We started with Debezium, then we moved to Google PubSub, then we moved to Dataflow, then we spoke about BigQuery and why would you go for BigQuery and how is it different from a traditional warehouse solution. Now let's move on to the demo. So I'll do a quick demo, and for this demo, I'll just follow this diagram, if you could see. So here on the left-hand side, I'll use Amazon RDS, a Postgre instance, and the right-hand side remains as it is. Okay, so let's move on to the demo. If you see, I have provisioned a database, which is provisioned on the AWS side. That's my DevCon NRT database. And if I move on to the Google Cloud side, I have a PubSub topic configured, NRT public actor. And if you see here, you get direct option of exporting it to BigQuery. And also you get options of exporting it to cloud storage. It could be either in your text format or either it could be on Avro format. So just see how easy and how simple is to do these things from your GCP console, how you can directly export your data to your BigQuery. So now let's create export to BigQuery. So when you do export to BigQuery, what it does, it creates a data flow pipeline in the backend. And using that data flow pipeline, it will be streaming all your changes, which are coming from your RDS to your Debezium, to your PubSub, and it would send it to BigQuery. So let's select Asia South one. And here, if you see, you have multiple data flow templates. So these templates are pre-created by GCP and provided to you. So we'll use a pre-created template called PubSub topic to BigQuery. So now when I select this, if you see here, there's an option of selecting a BigQuery output table. So we'll go to BigQuery. I already have a few tables created on which I'm working. But what I'll do is I'll create a new table for you. So I'll do a copy of this actor table. And I'd say actor underscore demo. Sorry, not this one, actor underscore demo in the copy in the table. So this table gets copied, but this table would also have the data copied from the actor table. So I'll just go ahead and do a delete so that this table is blank. So here we are using the JSON format. That's where we need to pre-provide the schema. Else, you don't need to pre-provide the schema. Okay. So now we'll use this table. So let's go to table go to details and fetch this table name. Let's use this table name here. The next thing is to put a temporary location. So I'll just go to GCS where I have created a temp location. So this is my temp folder. I just copy it and I'll just paste it here. Now I click on run job. So once I click on run job, the data flow job gets initialized and it gets provisioned. So very soon you'll see data flow getting created. Sorry, I'm using the same name. That's where it failed. Use defcon demo. Let's do a run job. So now if you see the view details, the data flow job is created and it's starting up. And if you see how soon or how fast it changed from starting to the running. Now what I'll do is I have a SQL procedure which just writes in some random data to a table. So my Debezium, I've configured it just to capture the snapshot of the actor table, which considers a number, first name, last name, and the current timestamp. So just run this procedure, and then I'll call this procedure to run. So now the procedure is run or it's executed. So the data would start flowing to my data flow job. It will take a bit of time because it's the first time that we have provisioned, but it would be real quick. You can check the logs from here. You have the worker logs and you have the job logs. And also, if you go here, you can see how many vCPUs are being used currently. What is the total vCPU time? What is the current memory? What is the total memory time, right? So if you see your latest worker status, so it's starting a pool of 1 workers, right? So now if you see it's processing my data, that's where it has increased from 0 to 4, and it has increased the current memory as well. And if you go down, it has all the details. It has all the details like what is the staging location, the template location, the temp folder location. And also in data flow, what you can do is you can put your own script. So you can write your JS code, which would help you in writing your transformation and extraction logic, which you can do in data flow. Right now, I'll just show the job step view and I'll see the table view. So if I see the table views, these are all in the running stages. And here, if you see the maximum number of workers acting is 3. So basically my data should have been processed and should now be visible in Bigquery. Let's go. We'll go to the Bigquery staging, actor staging, which is my data set. And inside this, we go to actor demo, which was the table which we created. Okay, so this data is not here still, but this data would come soon. If you see this query, this is on the actor table, which I was using earlier for my dry runs. So if you see here, there is data line. So 191 rows were published. And also, I'll again query our actor underscore demo table to show if the data is published. Okay, it's showing 0 data still, but that would get published very soon, similar to how it was in our actor table. So that's the complete demo. That's how the complete solution works. And I hope this would be useful, and you'll be taking it to different customers where you would be working on a multi-cloud strategy, and where you won't be confident on how to get data capture from one cloud provider to the other and use it for real-time analytics using BigQuery. Cool. So thank you, everyone, and thanks for your time.